In this session of CCNA series, we will discuss about different types of IPv6 address configuration and verification. There are two ways to assign or configure the IPv6 address on the router interfaces: static unicast address configuration and dynamic unicast address configuration. In static unicast address configuration, Cisco routers give us two options for static configuration of IPv6 addresses. In one case, you configure the full 128-bit address, while in the other you configure a 64-bit prefix and let the router derive the second half of the address, the interface ID. Configuring the full 128-bit address. To statically configure the full 128-bit unicast address, either global unicast or unique local, the router needs an IPv6 address/prefix length interface subcommand on each interface. Let's take a basic example. The figure shows the global unicast IPv6 address manually configured under interface FA0/0 with /64 prefix length. And the IPv6 address we have is 2001:DB8:4x1:4:2/64. The second option to configure static address is by generating a unique interface ID using modified EUI64. This second method uses rules called modified EUI64 or extended unique identifier. People refer to modified EUI64 as just EUI64. The configuration that EUI64 includes a keyword to tell the router to use EUI64 rules along with the 64-bit prefix. The EUI64 keyword tells the router to find the interface MAC address and do the EUI64 conversion math to find the interface ID. For interface gigabit 0/0/0, we have configured this prefix along with the EUI code with the IPv6 address. We have to use the IPv6 prefix 2001:DB8:4x1:1:64 along with the EUI64 code. This MAC address, the MAC address for this interface is 0013.1234.abcd. So to generate the unique interface ID, EUI64 rules are as follows. Split the 6-byte, that is 12 hex digit MAC address into two halves, 6 hex digits each. Then insert FFE in between the two, making the interface ID now have a total of 16 hex digits, that is 64 bits. Third rule, invert the 7th bit of the interface ID. The final step requires that you convert the first byte, that is first 2 hex digits, then from hex to binary, and then invert the 7th of the 8 bits and convert the bits back to hex. Inverting a bit means that if the bit is a 0, make it 1. If it is a 1, make it 0. After that, you can have this IPv6 address. Next, we have dynamic unicast address configuration. Cisco router supports two ways for the router interface to dynamically learn an IPv6 address to use. Number one, stateful DHCP, and number two, stateless address auto configuration or SLAC. Stateful address assignment. Similar to IPv4, IPv6 uses DHCP to statefully assign IPv6 address to any clients. Cisco IIS routers can be configured to be stateful DHCP servers. Stateful DHCP means that the DHCP server is responsible for assigning the IP address to the client. The DHCP server keeps a record of all clients and the IPv6 address assigned to them. The server can also offer other network parameters such as DNS servers, a domain name, or any other option that a DHCP server provides. The command used to get the IP from DHCP is IPv6 address DHCP. Next, let's discuss about stateless address assignment. This is a unique feature only to IPv6, also known as stateless auto configuration or SLAC. It is mentioned in which the device can obtain an IPv6 global unicast address without the services of DHCP server. Stateless address configuration means the client picks their own address based on the prefix being advertised on their connected interface. All Cisco devices have the ability to participate in stateless auto configuration or SLAC. By default, SLAC does not provide anything to the client outside of an IPv6 address and a default gateway. Moreover, it is important to note that SLAC most commonly uses EUI64 format for address assignment. This means that IPv6 address will be built from a combination of a layer 3 subnet prefix and the MAC address of the client. The requirement for SLAC is that the LAN segment must use a /64 mask. The command to configure SLAC is under the interface. You have to configure IPv6 address autoconfig. Both method, stateful and stateless, use the familiar IPv6 address command. Of course, neither option configures the actual IPv6 address. Instead, the command configures a keyword that tells the router which method to use to learn its IPv6 address. Next, we have IPv6 routing. This is important but often overlooked step when configuring IPv6 on Cisco routers. IPv6 routing needs to be enabled. On Cisco routers, IPv4 is enabled by default, but IPv6 routing is not enabled by default. The solution takes only a single command, IPv6 unicast routing, which enables IPv6 routing on the router. A router must also enable IPv6 on the interface using IPv6 enable command, which will enable the IPv6 on the interface. Let's take a basic example in which two different routers connected with each other and use a /64 prefix length. On router 0, let's enable IPv6 unicast routing. The command to enable IPv6 unicast routing is IPv6 unicast. Then let's enable IPv6 under the interface. Then let's configure the first type of IP address, IPv6 static address. I'll be using 2001 db8 4x1 1:1/64. So you are assigning the full IPv6 address. And then unshut the interface. Let me configure the IP address on router 1 as well. Enable IPv6 unicast routing, and under the interface enable IPv6, and then configure the IPv6 address 2001 db8 4x1 1:2/64, and then unshut the interface. For verifying the IPv6 address configuration, we have two types of command. Show IPv6 interface brief. This command gives you the interface IPv6 address, but not the prefix length info. As you can see, it displays only IPv6 address. There is no prefix information defined. The show IPv6 interface brief command lists all interfaces on the router whether or not IPv6 is enabled on the interface. For example, in this case, only one interface on R1 that have IPv6 address are as configured earlier. The second command we have is show IPv6 interface gigabit 0/0/0. This command output is about the interface only. Note that the output lists the configured IPv6 address, and also it shows the IPv6 subnet along with the prefix which the router calculated based on the IPv6 address. So next, let's configure the EUI64 type IPv6 address. The command to configure the EUI64 is IPv6 address prefix. Let's use another prefix 2001 2002 db8 222/64 EUI64, and you can verify your configuration by using show run config first. Here you can see I have configured another type of IP address command, IPv6 address command, along with the EUI code. Let's verify the same using the commands used earlier. Show IPv6 interface brief. You can see the router by himself has calculated the 64 bits by adding triple FE in between by using the MAC address. The same can be verified using a detailed command. Here you can see we have both the IPv6 address available. In IPv6 you can configure multiple IP addresses. Here you can see the subnet along with the EUI code prefix, and you can see the IPv6 address under the interface. The third type we discuss about is SLAAC. The command to configure the SLAAC is IPv6 address autoconfig. And then we can verify the same using the same commands. Here you can see the router has calculated the IPv6 address by himself. Same can be verified using the another detailed command. Here the router is displaying the IPv6 address and the subnet both. And the last command which we discussed was DHCP command. Since I don't have a DHCP v6 server available, so I'll be just verifying the command IPv6 address DHCP. I hope this